For this video, what I want to do is talk to you about the empirical rule, which is also known as the 68-95-99.7 rule. This rule applies to the normal curve, which is a bell-shaped distribution that is centered at the mean, and 50% of the data falls below the mean and 50% of the data falls above the mean. So a couple symbols that you may not be familiar with, this one that looks like an M and a U put together is known as mu. And this represents the population mean. And sigma represents the standard deviation. So what happens with the normal curve is it's centered at the mean mu, and if I go to the right, I add a standard deviation. So this would be the mean plus 1 standard deviation. This would represent the mean plus 2 standard deviations. This would represent 3 standard deviations above the mean. If I go to the left, I subtract the standard deviations. So this would be the mean minus 1 standard deviation, or 1 standard deviation below. This would be 2 standard deviations below and 3 standard deviations below. What the empirical rule, or the 68-95-99.7 rule, tells us is that approximately 68% of our data falls within 1 standard deviation. Approximately 95% falls within 2 standard deviations, and approximately 99.7% of our data falls within 3 standard deviations. So almost 100% of our data falls within 3 standard deviations. So anything that is more than 3 standard deviations is considered extremely unusual. Anything more than 2 standard deviations is typically unusual. If it falls between -2 and +2 standard deviations, that's what we would expect to see. All right. So there are a couple things that you can do to make this a little bit easier if you're answering questions with this. Because of the fact that we know that this is a symmetric distribution, we can take half of the 68, and that tells us that approximately 34% of our data falls between the mean and 1 standard deviation above. And we could do the same thing for below. Okay. We could also look at the fact that we know that 95% falls within 2 standard deviations. So if we take half of 95, we get 47.5. We already have 34 here. So what would be left is 13.5%. And sometimes I go ahead and fill these in just to make some of the other questions that I'm going to ask a little bit easier. You don't have to do this, but it does make some things easier, especially if you are doing several problems with this. You can refer to the chart. Okay, this part right here is going to be 2.35%, and again we could take half of the 99.7 and then subtract out the 47.5 to get that value. Okay, and then the very last little tiny bit right here, we know that if we take 100% minus 99.7%, we get 0.3%. So in total, 0.3% falls in these two little tails. So since it's symmetric, half of it would fall here, which would be 0.15%. And then half of it would be here, which is 0.15%. And if I added these all up, that would give us 100%. If I added the values that are above the mean, this would add to be 50%, and this would be 50%. So we're going to use this to kind of help us out with the following questions. All right, so a population is normally distributed with a mean of 42 and a standard deviation of 3. So what we're going to do from this is we're going to take and draw out a bell-shaped curve, or a normal curve. And just draw them the best that you can. Sometimes mine turn out better than others. And then we're going to center it at the mean. So in this case, we would center it at 42. And then anything to the right, we're going to add 3 to go to the next point. Anything to the left, we're going to subtract 3 from that value. So that's what this is telling us at the bottom here, that it's centered at the mean. To go to the right, we add. To go to the left, we subtract. All right, so if we go approximately 1 standard deviation above, we would add 3. That would put us at 45. If we go 1 standard deviation below, we would subtract 3, and that would put us at 39. Okay, if we go 2 standard deviations below, that would put us at 36, because I just do 39 minus 3, or I can do 42 minus 2 times 3. That would get us the same thing. Okay, going to the right, we would add 3, so that would put us at 48. And then our last one, if we add 3 again, that would put us at 51, and if we subtract 3, that would put us at 33. So when they ask you to draw a model, this is what they're looking for, and remember that we can say that approximately 68% falls here, approximately 95 falls here, and then the 3 standard deviations is 99.7%. So we're going to use this model to answer a couple of questions. The first 2 I'm going to try with you, and then I have 2 you try questions that you can try on your own to make sure you understand. And then after you try the you tries, just resume watching and do them on your own. So we will be using this chart for the following 4 questions. All right. The first thing that we want to do is find the percent of values that fall between 36, and I wrote that down wrong. That was supposed to be a 45. Let me fix that really quickly. Let me grab my eraser. Sometimes when I'm writing numbers down, I flip them around in my head. All right, so this was supposed to be 45. I saw that number and I realized it was incorrect. All right, so from 36 to 54, there's a couple different ways that you could do this one. Number 1, what we could do is we could look to see that from 45 to 39 is 68. So we know that 68% of our data falls. Okay, and then we can go up to how we broke it down up here and see that 13.5 falls in between 1 and 2 standard deviations. So we could say that this is 13.5. Okay. Another way that we could have got this, and I'm just going to say 81.5% is the answer. Okay, that's not the only way that I could have done that. Another thing that I could have done is I could have used the fact that from 36 to 42 is half of 95%, which is 47.5. And then we knew that this one was 34, so I could take the 47.5 plus the 34. That would also give us 81.5. So we could have done 47.5 plus 34, which is also 81.5. Or we could have said that we know that there's 2 standard deviations within is 95, and then this little part right here is 13.5. So we could take the 95% minus the 13.5. All of them arrive at the same answer. It's just a matter of which one is easier for you to see. I always like to give lots of options for my students because I know that all of my students look at things differently, and it's okay to get to the same answer in different routes. All right, the next question asks us approximately 95% of what values fall between, or of the values fall between what 2 values. So this time they gave us a percentage, so they're just wanting us to use the values. So the 95% is from 36 to 48. All right, so I have 2 more that I want you to try. I want you to find what percent of the values fall above 39, and approximately 68% of the values fall between what 2 values. So go ahead and pause the video, try answering these 2 questions in reference to this chart right here, and hopefully you took the time to write it down on your paper just so that you can learn a little bit better. If not, go ahead and take the time now to write it down and then try these 2 questions. All right, now that you have had a second to try this, we're going to look at the values here. So since 39 is here, we're looking for everything above this. The easiest way for me to do this is to see that I know that everything above this is 50% above the mean. 50% of our values fall above the mean. And I know that this part right here, there's 34%. So the way that I would do this is I would take 50 plus 34, and we would get 84%. Okay, and then for the last question, approximately 68% of the values fall between what two values? So 68% fall between 39 and 45. Okay, and when you're asked questions about the empirical rule or the 68, 95, 99.7 rule, the questions that are asked in textbooks will refer to these values here, so it's always a good idea to draw out the picture. If you are dealing with something that doesn't fall on here, then you would actually have to use either the normal table or a graphing calculator that has the normal distribution in there. I do have videos that show how to find the area under the normal curve, so you can always check those out if you have values that do not fall on here. But most of the time when you're dealing with the 68, 95, 99.7 rule, you are dealing with values that fall exactly 1, 2, or 3 standard deviations above or below the mean. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics you need me to cover, please let me know that as well.